Alright, we're on lesson 3. We're continuing with exponents and with fractional exponents, and today we're going to talk about the relationship between those and radicals. Remember the radical sign from Algebra 1? It's like a square root sign. Okay. The number on the inside here, if we had, let's say, square root of 4, right, we are saying what's the square root of 4. And why do we call it the square root? It's because we are assuming that there's a number here that's in place. The number that's assumed there is 2. This is called your index. And this is called your radicand. You can write this down as I go. This is just some prior knowledge you should already know. And sometimes the index is different than the radicand, of course. And what the index does is super important, because the index could be any number. It could be anything 2 or larger. So it could be 10. What it's asking on this case, since it's 2, it's saying what multiplied by itself will equal the radicand. What multiplied by itself twice will equal the radicand. So what times itself will equal to 4, everyone? 2. What else will equal to 4? No. I'm sorry, what else will equal to 4? No. Let's start over. What times itself will equal to 4? What was your first answer? 2. Okay, what else would equal to 4? Negative 2. Right. Good. Negative 2, right? Negative 2 times negative 2. So when we have the square root, in this case we have 2 answers. Okay. What happens if it's the index is 3? Okay. Let's look at this one. You kind of looked at this yesterday. This is called the cube root. Think about this. What times itself 3 times will equal to 27. 3. Good job. You remember that from homework last night, right? A girl. So 3, right? 3 times 3 times 3 is 27, right? Does that make sense? What about negative 3? Does negative 3 an answer to this? Yes or no?
Yes.
No. Think about it. What's negative 3 times negative 3? Fake out, right? Just kidding. Negative. It's going to be 9. And then what's 9 times negative 3? Negative 27. Is that the same thing as 27? No. So you have to be careful with what your answer is going to be. Does that make sense so far? Okay. So the index is super important, and so is the radicand. So you have to think about it. Sometimes you have 2 answers. Sometimes you have 1. Okay. This is stuff you should already know. This is prior knowledge. So today what we're going to do is combine what we learned yesterday with the fractional exponents. Remember the exponents that had fractions in them. We're going to convert individual expressions into radicals, and then vice versa, go backwards. It's actually pretty easy. It's just a way to understand how to manipulate the math language, right? Math is a language. We're going to learn how to read it and process it. Okay? So, continuing on. These are the steps of starting with a fractional exponent. Rewrite the expression as a radical with a number on the outside of the parentheses, and the denominator as the index. If starting with a radical, work backwards, okay? These are the steps. If you're on the video, you should pause it now. I'm going to move on to examples 1 and 2. Okay, examples 1 and 2. Okay, pencils down, just watch the screen. So rewrite as a radical or fractional expression. So number 1, it says k to the 3/4. Let's say you were just focusing on one expression. The expression was k to the 3/4, or one term. If you wanted to convert this to a radical, all you'd have to do is take take the base of k and put that into its make it a radicand. Okay. The index will be the bottom number, so you put that down here as the 4. Then you put parentheses around the whole thing, and you put the numerator as the new exponent at top right here. That's it. So it's really like saying the 4th root of k all raised to the power 3 times. Okay, that's all we're doing, is just converting it. We're not calculating anything, we're just converting it. We're manipulating it. Okay? Again, what did I do? Took the original problem, it says to write it as a radical, so all I'm doing is saying k to the 3/4. This is my base. Bringing the base down to the radical sign as the radicand. taking the denominator, making it my index, taking the numerator, making it an exponent on the outside. And then that's your answer. You don't have to write it twice. I wrote it twice because it's kind of messy, right? Does that make sense? Now, number 2. Look up here. We're just going to think backwards. Same type of problem. We're just thinking backwards. Okay, so we know 6r is the radicand. So I know 6r will be my base. Since 5 is on the outside of the parentheses, it's going to be my numerator. And 3 is on my index could be in my denominator. And since 6r is all in my radicand, I want to make sure, look up here, this is super important. Pencils down. Super important. Since 6r is in my radicand right here, it has to be in parentheses because the whole exponent applies to both the 6 and the r. If you leave it without parentheses, you're saying just the r has the exponent. That would be wrong. So you must put the parentheses. Okay? Whatever's inside the radicand has to have parentheses. Whatever's inside the radicand has to have parentheses. You got it? Okay, good. So, that's all we're learning today. We're just converting between radical expressions and fractional exponents, okay? Cupcakes. So let's have 1 start today. 1s will talk about number 1 to their neighbors. Before you start writing, no writing it. And then 2s will talk to their neighbors after number 1s are done. Ready, set, talk. Okay, so continuing on here. Hopefully this turns back on. Okay, here we go. Number 3. Please rewrite that as a radical expression. We have a to the 1/2 power. A to the 1/2. I'll give you 30 seconds. Looking up here at number 3, we have a fractional exponent. So all we do is take the base, bring it into its own radical sign, take the denominator, put it into the index, and take the numerator, put it outside the parentheses like so. Okay, this is an answer, but what's anything to the 1 power? 1. No. Anything to the 1 power is what? Itself. Good. So then you don't even have to put it in parentheses. You could just leave it like that. And one more thing. What number do I assume is in my index when there is just a radical sign like this? I said at the beginning of the class, we assume it's 2 because this is called a what root sign? Square root. Square, right? So this is, we assume there's a 2 there. Does that make sense? Okay. So I don't take this first answer or the last answer. This is the best one. The best one is actually the last answer. This is simple. But if you did the first answer, that's good. You did what I asked you. Okay, good. Number 4, try it out. Go. Oh, no. Sorry. Four. On number 4, you take the base, 6n, put it into its own radical sign, the whole base. Take the denominator of 3, put it as the index, parentheses around the whole expression to the 5th power. This is the correct answer. This is the only correct answer. Okay? Make sense? Now we're going to work backwards. Okay, number 5, go. Zoom. Okay, so right here, all we're doing is we're taking the radicand of x, putting it as the base, and then we have 7 as our numerator, 5 as our denominator. Okay, number 6, I'm going to make one for 6. Okay. Number 6, what I'd like you to do is the following. Let's see. 4th root of 2 all to the 8th power. Go. Last one. Yeah. This is 8. Yeah. 4th root of 2 all raised to the 8th power. Were you able to get online last night? Okay, answer's up. Okay, good. So most of you are following through. Remember, you always want to simplify math, so check this out. The answer here, look here. Don't erase your boards because I want you to see what you did, because all you, or a lot of you got it wrong. There's only a couple of people that truly got it all the way right. So if you started with 2 to the 8/4 power, then you're in the right direction, right? Raise your hand if you at least got to there. Good. What's 8 over 4 as a fraction? Can we simplify 8 over 4? Yeah, it's just 2. 2 squared. What did I say about exponents that are 4 or less? Should we expand them? Yeah, what's 2 squared? 4. The answer here is 4. So if you can work it out, work it out. Okay? Because that's what math is. I want to let you know every year, I want you to know that I tell students, and I want you to believe this, math is not there to intimidate you. It's a tool. It's kind of just part of the life we have around us. We want to use it and manipulate it to the way we want, okay? Which means simplifying it and working it. You don't want to make math so intimidating. Because you know you all are doing a good job so far. I really believe you're going to have a great year, okay? So you can do this. You're all very smart. You're already in Algebra 2. All right, that concludes our lesson. So, turn to your neighbor. Explain, what do we learn? How do we do that? How does this fit in math? And how might we use this in real life?